Yesterday we talked about the volume of prisms, which, if you remember, is found by doing the area of the base times the height, big H. Today we're going to be talking about the volume of pyramids. It's almost exactly the same thing. Here you have a prism. Let's say that we're actually going to now fit a pyramid with the same size base inside this prism. When you look at it, you can see that it's exactly the same volume, except it looks like someone has shaved 2/3 off of it. The first example we're going to use has a rectangular base. We see that the base is a rectangle with a length of 8 yards and a width of 6 yards. The total height, or big H, is 12 yards. We're just going to go ahead and label that big H now. You're going to recognize the formula that we use to find the volume of pyramids. At first, the formula looks the same as the volume for a prism, the area of the base times the height. But because we're shaving off those 2/3 of that prism shape, we are now going to divide everything by 3, or you could say multiply it by 1/3. So it's the area of the base times the height, and that entire thing is then just divided by 3. Let's start filling in the formula for this particular shape. We are remembering that the base is a rectangle that looks like this, 8 yards, 6 yards. So the area of a rectangle, we're just going to fill that in. We don't have to do anything fancy. Little base times little height, or 8 times 6 times the height, big H, or 12. That's exactly what we would do if we were finding the volume of a prism with the same base. But because it's a pyramid and we're shaving off those 2/3, we divide everything by 3. Now you could use your calculator right away to plug that in. I'm just going to point out here, I see that 6 and 3, or 3 and 12 have common factors. I'm just going to choose 6 and 3 to use. 6 and 3 have common factors of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. When we simplify that down, it becomes 8 times 2 times 12. All over 1, but we don't have to write that. What we'll get in the end is 192 yards, and because it's a volume, we write cubed on the units. That is the volume of our pyramid. Let's do another example, but this time we're going to do a pyramid with a triangular base. We see that this is a pyramid that has a right triangle for a base. The right triangle, if we were to draw a little picture of what the base looks like, would look like this. With a height of 9 and a base of 5. The total height, or the height of the entire pyramid, big H, is 10. So we're going to label that right away. The first thing we always do is write our formula. So let's go ahead and do that. Volume is equal to area of the base times big H, or the height, all divided by 3. The only problem we have now is that the area of the base is no longer just little base times little height. It's not a rectangle anymore. Let's take a little chunk of space here and figure out what the area of the base is. I'm going to put it in a box. Because it's a triangle, we know that the area of the base is the formula for a triangle, little base times little height, all divided by 2. What we're looking at is this triangle here, our base. So I'm just going to fill that in with area is equal to 9 times 5, all divided by 2, or 22.5. Going back to our formula, let's finish filling that out. Our volume is equal to the area of the base, which we just found to be 22.5, so we plug that in here. Big H, or height, the height of the pyramid, is 10, and it's all divided by 3. If we continue to simplify that, we will get that the volume is 75. Our units are meters. Meters cubed. Because it's a volume, we write the cubed on the units. And that is the volume of this pyramid.